Hey geometries. So here's a fun factoring review. I want you to go ahead and take a look at this worksheet. Use the digits 1 through 9 and fill in each of the factor tables. So the way this works is, I know 16 breaks down into 1 times 16, 2 times 8, and 4 times 4. So I've used the 4 and I've used the 8, and now you have to go ahead through and use each of the other digits. So pause the video and go ahead and fill in each of those values. All right, let's see how you did. Filling in each of those values should have been easy. Back to 3rd grade math fact tables. But what I want you to think about is having a systemized and organized way of looking at the way that we can break down each of these products into its factors. So these values are factors, and the idea of what you're doing is factoring. All right, next we're going to look at this part of the worksheet. Examine the following X's. Study the relationship between the numbers, their values, and their positions. Then I want you to describe the pattern that you notice. All right, how did you do? When you look at the relationship between this value, this value, this value, and this value, you can see a pattern when you can see that 9 plus 4 is equal to 13, and 9 times 4 is 36. When if I have 12 and 1, their sum is 13, and their product is 12. Interesting here, if I have a negative value, it is still a sum, even though we actually know it's a difference because one of the values is negative. And notice that gives me a negative product. So when you write down that pattern, make sure you have the fact that you're talking about them adding or having a sum for the number on the left and then multiplying and having a product on the right. So your goal for this part of the worksheet is to fill in the missing numbers that fit that pattern. All right, let's check it out and see how you did. So for these first couple ones, it's pretty simple. The sum of 8 and 2 is 10, and they have a product of 16. The sum of 9 and 3 is 12, and they have a product of 36. This is an interesting one. Because I saw a negative in my product, I know that one of my values had to be negative and one had to be positive. When I check out the sign of my difference, I know I need to have more negatives than positives because I ended up with a negative sum. Now for these, if you put a 3 here and a 9 here, no big deal. If you put a 2 here or an 8 here, no big deal. If you put the 3 here and the negative 8 here, no big deal, but you need to make sure that this negative is on the 8 and not the 3. Because that does change the value then of your difference. So these next 3 are a little tricky. Let's see how you did with these. If I have a sum of 0, that means that my 2 values are a 0 pair, positive and negative 3. If I have a sum of negative 7, negative 1, negative 6, but notice I have a positive product because a negative times a negative is a positive. If I have a sum of 22 and a product of 21, that is from 21 times 1. All right, so flip over on the back. And what we want you to do is pay attention to the product and sum. And I want you to come up with two factors. Find two factors whose product and sum is as indicated. If I have a negative product, one of my values is going to have to be negative and the other is positive. If I have a positive sum, that means that I have more positives than negatives. So go ahead through and fill this in and check your work when you're done. All right, how did you do? Make sure that you do your work first and then you check your answers. So I had 2 that I thought were kind of tricky. If I look at negative 32, the only factors of 32, and this is where the tables on the front come in handy. When I look at 32, my factor table is 1 and 32, and 2 and 16. 3 does not go in evenly, but 4 and 8. And this is where I wrap around because the commutative property says that each of these factor combinations work both ways. Because my product is negative, that means that I need to find two numbers that have a difference of 3. It's not going to happen. So here my answer is none. When we look here at my other none, when I look at 25 and I do a factor table, 1 and 25, 2 does not go in evenly, 3 does not go evenly, not 4, but 5 does 5 times, and that's my wraparound. Because this sign is positive, I know both of these signs are going to be negative because I need a negative times a negative to get a positive. So when I go and I look together, even though this has a difference of 24, I'm looking for a sum, so it doesn't work out, and I have a none. There were definitely a couple of tricky ones here, so we'll let you double check your work with mine and come back to class with questions.